Okay, so today we will be discussing about 10th lab program. It is on binary search trees. Okay, so before starting the implementation, let us check what is there in your syllabus. Okay, so this 10th program is on designing, developing, and implementing a menu-driven program in C, like we have done in the previous cases also. Okay, for the following operations on binary search trees. Okay, so you already know what is a binary tree. Let us understand what is binary search tree. There is some slight variation in binary tree and binary search tree. So this program is on implementing binary search trees. Okay, and also you have to write a menu-driven program for few of the operations specified. So what is the first operation is you have to create a binary search tree of n integers. Okay, so you can the data part can be anything, as you know, for a tree. When you consider a node, the data part can be integer, character type, or any other expression also. But here in this example, while considering the binary search tree, first operation is to create the binary search tree for given integer values. Okay, n can be anything. So user can specify the value of n. So depending on the number of elements, the number of elements can be any value given. Okay. So you have to construct a binary tree for the value given. It is not mandatory that you have to give this value only. Okay, you can give any other value also. So as of now, first operation is to create the binary search tree for the given n integer values. Okay, after this we will understand how to create the binary search tree for the given values. So next is to perform the traversal. As this is already discussed earlier, traversal of binary tree. Okay, so traversal of binary tree and binary search tree are both same, will be following the same method. Okay, in this case, you have to write the implementation for traversing in in-order traversal method, pre-order and post-order method. Okay, this already we discussed earlier also. Okay, so we are applying the same method for the binary search tree. Okay, implementation wise it is same thing, but it is applied for the binary search tree. That is the second operation. Third operation is search the binary search tree for a given element. Okay, you will be given with a key element. So key element indicates that data which is present in your node. Every tree will have your data part specified. So you have to search for the particular key element specified by the user. Depending on the search, whether the element is found or not, you have to identify. If the element is found, the search is successful. Otherwise, search is unsuccessful. Okay. So if it is found and if it is not found, also you have to display the appropriate message. Okay. You have to report the appropriate message. That is the third case. Okay. So third one, you will be searching for the key element. Element can be integer type because we are considering the integer type here. That is the third operation. Fourth one is the exit case. Okay. So here in this example, you will be writing a menu driven program for doing all this operation. First is creation. Second one is traversal. Third is searching the key element. And finally the exit case. Okay. So before going for the implementation part, let us understand what is a binary search tree. So you already know what is a binary tree. Can anybody tell me what is a binary tree?
Each node having maximum 2 degrees.
So each node will be having the degree maximum equal to 2. It cannot have more than 2. So similarly, it is also a binary tree, but the difference here is we will understand with respect to the given number of integers. Okay, suppose if the values are given like this, consider you have some integer values 4, 15. It is just the random values I am considering 10, 20. So this is used for constructing your binary search tree. 20 is given and next I'll just consider 2. So let us understand how do we construct a binary search tree for the given integer value. This is given already. So using this, we shall now construct the binary search tree. And what is the rule for constructing binary search tree is, First thing, you identify the root node. Root node will always be considered as the starting node in your integer sequence. Okay, starting digit in your integer sequence, that is 4. So I'll consider 4 to be my first node and I'll consider that to be the root node. Okay, so what is the general rule identified for constructing your binary tree is, so you have to write the tree such that the value which is present in the left side, or I can consider that as a left subtree of your complete root node, will be indicated by lesser values than its root node. Suppose 4 is present at the root node, in the left subtree you can have the values which are less than 4. That is the rule. And also, what about right subtree? Right subtree should have the values which are greater than the values of your root node. Okay. As of now, we have considered 4 as the root node. So if 4 is considered as the root node, its left subtree. Okay. I just repeat it. If the left subtree is present, so left subtree should have the values lesser than your root node value. Okay. Whereas coming to right subtree, it should have the values greater than the value of the particular root node. Okay. I just indicate here. So left subtree, if you consider left subtree, it should have less than the value of its root. Okay. So if 4 is considered, all the values which is present at the left part should have the values less than 4. And what about right subtree? Right subtree is defined such that the value is greater than the value which is present at the root node. Okay, so this is not only for the root node. When you consider any other subtree, okay, for the subtrees also you have to consider this rule. Let us understand for the given sequence. Now we have considered 4. So after 4, next is 15. Okay, when you have 15, so the 15 value is greater than value of 4. In such case, how you have to append? You have to append 15 to the right side of 4 because 15 is my highest value. Okay, this is 15. We have considered this to be 15. Okay, so first two values have been completed. Next, you check for the second next sequence in your given input. Okay, so next digit we have is 10. When you consider 10, compare it with the root node. Okay, when you consider 4, so 4 is lesser than 10, and also you check with next is you check with 15. When you check with 15, 15 can be the root node of the right subtree. Okay, so when you consider 15, so what happens with 10? Where do you place 10 now? Because
Left
15 is higher than 10. Where it should
Le-
be placed now?
Left side
side
of
of
Left
50.
side.
So it should be placed to the left side of 50. Okay, 10 should be placed to the left side of 50. Similarly, check with the 20. So next value is 20. 20 is higher than 15. Okay, since it is higher, directly I can place to the right side of 15. Okay, I can directly place 20 here. Afterwards, you have 2. Where do you place 2? 2 is less than the root node value.
left side of 4.
So I can directly place it to the left side of 4. Okay, this is where I can place 2. Next value is 6. Where do you place 6? 6 is higher than the root value. Then it should come towards the right part of your root node. Okay, when you consider the right part, so compare that with 10. So 10 is higher than 6. Where it should be placed?
Left side of 10.
Left side
It,
of 10.
it should be placed at the left side of 10. Okay, this is your binary search tree constructed. Okay, so you have to remember this rule always when you consider any of the root nodes. You can consider any of the subtree. Okay, always its left subtree will be having the lesser values and right subtree will be having the greater values. Okay, so in your question, so they will be given with, or you can also consider the values of n. If you consider the values of n, you can randomly assign the values. Okay, randomly you can give any integer values based on the n considered. Then you can start constructing this particular tree. This is also one of the important topic. We are going to study this in theory as well. Okay, so this is how you have to construct. Only rule is you have to remember this particular concept. Left subtree should be less than the root value and right subtree should be greater than the root value. This is true for all the subtrees considered. Okay. So now this is your first operation in the question specified. You have to create the binary tree. Okay, this kind of tree should be created. So to differentiate what is the left child and what is the right child for individual nodes. After it is defined, next is to apply your in-order, pre-order and post-order traversal. So once the tree is defined, I think you can be now easily answer that particular question, in-order traversal, pre-order and post-order. Can you people tell me what is the in-order traversal value for this? Sequence, in-order sequence?
2,
2,
2,
4,
4,
6,
6,
10,
10,
15,
15,
20.
20. Okay, so in order you follow that left, right, and node method. So we are going to apply the same method here. Okay, so first step is easy. When you just construct a tree, then next is you have to apply the methods. Okay, your traversal methods, in order, pre-order. So pre-order is you have to visit the node first, then you have to visit left and right part. Okay, so can you people tell me for this one, pre-order?
मैम इन
4,
In order?
मैम इन ऑर्डर के लेफ्ट टू नोड राइट परफेक्ट मैम लेफ्ट राइट नोड ಬರ್ತಿದ್ದೀರಾ
Okay, okay. Correct. Left node and right. Okay. Pre-order?
4,
4,
2,
2,
15
15,
10
10,
10,
6
6,
20
6,
20.
20. Okay. Post order? It is left, right, and node.
2,
2
2,
15
15,
15
after 2, is it 15?
no ma'am 6 ma'am
6,
So after 2, you have to check for the right subtree. Okay, when you check for the right subtree, it still has a tree. Okay, I can consider this as a tree. When you consider this as a tree, you have to check for the left part. Okay, so left part again it has a tree. Again go with the left part. What do you get after 2?
6,
So you will be getting 6, correct?
yes ma'am
Okay, then
10
10,
10,
20,
20
20,
15,
15
15,
4.
4
4, correct? Okay, so 4 you can indicate here. Okay. So this is the in-order, pre-order and post-order traversal for the given binary search tree. Okay. So the concept here is very simple actually. So you'll be given with the n values. Based on the n values, you have to construct the tree. First step is to create the tree. Okay. Once the creation is done, you can easily apply in-order, pre-order and post-order method for the given tree. You can consider any value of n and also you can construct the tree and is you have to search for the binaries, you have to search for the key element. Okay, so key element can be any one of these values or it can be other than this value also. Okay, so how do we search? Okay, when you consider binary search tree, There is an advantage here for searching. What is the advantage? Because you already know the location. When you consider the root node, you already know that the left part of that particular root node has lesser values and the right values of that particular root node will be having greater values. Okay, so with this advantage, the searching becomes easy when you compare it for arrays or other linked list concept, singly linked list concept, or just a binary tree searching method. Binary search tree will have better performance compared to other. What is the main advantage here is you know what subtree will be present and what will be the contents of each of the subtree. Okay, so if you consider any of the subtree, you can consider this subtree also because this is also considered as a tree. When you consider this subtree also, you know that the value of its left part or the left subtree will be having the lesser values than its root node. And also you know that its right part will be having the values greater than its root part. Okay. So with this logic, definitely searching becomes easy. Okay. Suppose the key element, how do you search and what is the logic for searching is you start it with the root node. Okay. So suppose consider an example. Now I am trying to search 2. Okay, so I'm trying to search 2. When you want to search 2, this is the key element considered. When you consider this to be equal to key, you will start with the root node. Okay, so you compare that with particular data given. I have to search 2. Now I'll compare 2 with the root node. Okay, you can compare 3 ways. One is whether it is equal to my root node, or whether it is less than my root node, or whether it is greater than my root node. Okay, you can search it in 3 ways. Suppose if it is less than the root node, what you can do? Directly you can go to the left part because it is having the lesser values. Suppose the input value is greater than the root node, directly you can go with your right part. Okay, that is the advantage of binary search tree. Okay, so this is the concept. You have to search for the tree. Okay, search for the particular key input. So based on the key inputs, if the search is successful, you can display the message that key is found. If it is not found, you display that as the particular key element is not found. Search is unsuccessful. Okay, that is the advantage of searching with binary search tree methods. The name itself indicates, you can say the binary search tree. So searching operation, main application searching operation will be easy compared to your earlier methods. Okay, so this is the concept here. Okay, we have to perform all these cases and implement a function in C. For each of the operation, you have to implement the function. Okay, so and there is some variation in binary search trees also. Okay, you have deletion methods also, but in question they have not mentioned doing deletion of any of the nodes. Consider, suppose you want to delete a node. Consider I want to delete 15. So in order to delete 15, what are the changes to be made? Can anybody think of the changes if I want to delete 15? If 2 is to be deleted, it is easy. Directly I can delete it. If 6 is to be deleted, I can delete 6 easily. Suppose if 15 is to be deleted, what are the changes to be made? What you need to check?
Man,
While
20
doing
should,
the deletion operation.
man, 20 should be root node.
So how do you check? How do you compare this? Can 10 be a root node or 20 be a root node?
And 20.
Why 20 should be the root node?
ರೂಟ್ ನೋಡ್ಗೆ ರೈಟ್ ಸೈಡ್ ತಗೋಬೇಕು ಅಂದ್ರೆ ಅದು ಗ್ರೇಟರ್ ದ್ಯಾನ್ ರೂಟ್ ನೋಡ್ ಇರಬೇಕು 20
Okay.
ಗ್ರೇಟರ್ ದ್ಯಾನ್ ಇರೋದ್ರಿಂದ
Okay, so that is the logic you should apply. Okay, you have to verify whether it is greater or lesser values. After verifying it, because 20 should come to the right part. Okay, so how do we identify that? In that case, you have to check with the particular deleted node. Suppose 50 to be deleted, you compare it with the left part and also compare it with the right part. If the value of the left part is having lesser values, you can directly use that to make it as a root node. Okay, directly you can delete 15, make 10 as the root node and append to the right of it, append 20 to the right of it. Okay, so that we are going to study this in theory. As of now, it is not there. Deletion is not there in your question. Okay, this deletion method, we are going to study that in theory. Okay, after your threaded binary trees. As of now, no need to worry about deletion now. We should not implement deletion concept here. Here only to create, do the in order, pre-order and post-order traversal, and also search for the key element. Okay, any doubt in the concept? So are you able to write the binary search tree for any of the given sequence?
Yes, ma'am.
Okay, we'll start with the implementation. And what is the node structure? Is it same as binary tree?
Yes, ma'am.
So node structure is same as the binary tree, that it should have a left part, right part and the data part. Okay. So start with the normal declaration, header files. And I need stdlib for your malloc or malloc function. And then you need a clear screen operation, conio. Okay, so now declare the structure. Okay, while defining the structure, you need to identify the data members of the structure. I'll consider this as BST, that is the name of the structure. BST indicates it is binary search tree. That is the short form considered for binary search tree, BST. And you already know the node structure for binary search tree. It is same as binary tree. It should have the data part. And what is the data part? Data part here, it should be the integer type, because we are considering the integer type according to the example question. It should have n number of integer data elements. Okay, so next is you should have the left part and the right part, that is the left child and the right child. So to do that, you should have two pointers for the left and also for the right, and we shall consider that as a self-referential structure, because when you have a left pointer and the right pointer, it will point to the next node, which will also have the data part and the link part. Okay, so normally we consider the same thing. Similarly, like previous examples, left child and also the right child. Okay, so this is the structure declaration. Okay, so afterwards you can define the structure variable. Binary search tree, I'll indicate to be equal to node. Okay, to differentiate, I'll just keep it as capital because we'll be using node later also. I'll consider this to be a node, that is a structure variable. So this is the structure declaration with the data part and the link part for binary search tree. Then we will start with the main function. So in main function, they have mentioned that it should be a menu-driven program. How do you create a menu-driven program?
Using switch case.
So using switch case. Okay. For doing that, I'll consider choice, and I need a for loop because it should be done for n number of characters, or for n number of integers. Because it is asking for n number of integers, I'll take n and I for the for loop for doing the iteration, and data for fetching the data, means your integer data. You need to take that particular thing. So all this I'll consider to be equal to integer type. So afterwards, when the tree is empty, your root node will be initially null. Okay. For doing that, we will initialize your root node. I'll consider a variable called root because still we have not created your tree. Since this tree is not created, what should be the initial case for your root? Initial condition for the root should be equal to null. Okay. So node is a structure variable. Using the structure variable, I am defining another pointer called root, which can also hold the data part, left part and also the right part. Okay, since the tree is not created, we have initialized that to be equal to null. Afterwards, you can go with your clear screen option. Okay, then you go with the choice. We have to specify the choice. We'll go with a while one because the menu should be repeatedly displayed. Okay, so what should be my first choice? According to the question, I need to create binary search tree, right? Okay, that is the first choice. Second choice is you need to search for such element in binary search tree. Okay, so either you can go with the second choice itself for traversal. It is not mandatory that you have to follow the same method. Okay, so third I'll go with the traversal. If you want, you can include the traversal in the second step itself. Then you can go with the searching. So there is no link between searching and traversal. That is different, and traversal is also different. So then fourth choice is exit case. Okay, so while doing the traversal, directly you can specify the traversal, all the methods in the single function, or you can also go with different choices for individual traversal methods. Like in order, you can consider choice 3, pre-order 4, post-order 5, that can also be done. So since it is not required, I'll just consider all the traversal methods in the same choice. Okay, if I click choice 3, then it will display all the traversal methods. Finally, it is the exit case. Okay, so then printf statement for entering the choice. Enter the choice. Then scanf for reading the choice, getting the choice from your keyboard. Ampersand ch is the variable we use for choice. Then we start with the switch case. Okay, switch ch. Start with the first case. Okay, follow the proper indentation while typing so that it is easy to analyze if you get any errors. So what is case 1? Case 1 is to create the binary search tree. Okay, so while creating the binary search tree, I should know the total number of elements. First thing is I should know the total number of elements before reading those elements. Okay, for getting the total number of elements, how we can consider, you can directly go with enter the n value, or enter the number of elements also you can consider. Okay, so this is only for reading the value of n. Then specify scanf for retrieving that value, ampersand n. Okay, so once the value of n is known, next is to read all the values. Okay, now you can specify, enter the values to create binary search tree. For binary search tree, I'll just indicate it as BST. Okay, so like how do you give input? If it is confusing, I'll just indicate input can be anything like this. Okay, so it is not mandatory that you have to give the same values. You can give any other values. Just for example, I'm considering this. It depends on your input. Okay, so afterwards, since we are reading n number of values, I need a for loop. Consider the for loop because you are reading the n number of values. After you read the n number of data, next is you have to create that particular binary tree. Okay, so we will consider a for loop for reading the data for n number of values. Hence, we have considered we have declared I also. Okay, for then read the value scanf percentage D because it is an integer. So we have defined data variable for that. I'll just indicate here, okay, ampersand data. Okay, so what we have to do here, we have read the input, that is n number of values, and for each of the n, for a particular value of n, you have to read each of the data element like integer values. Once it is done, for each of the data, means for each of the integer values, I have to create the tree or your node should be created. Okay, for creating that, I'll just call a function called create tree. Okay, this is a function call. In this function call, you will be passing the value of root node and also the data because data is exact value of node. Okay, so for that your the return value will be stored in a variable called root. Okay, this is a function call. We have to write the function definition. Normally, like other programs, we have to write the function definition for that. So here I am just calling the function in the for loop itself. Okay, remember that I am calling the create function in the for loop itself with the input parameter root. Root is initial value, that is the first node in your tree. Initially it is equal to null. We have defined it as empty because still it is not created, and the data is the first data you enter, first integer data. Okay, it will be repeated for the value of n until the last value of n. We will be scanning the data part and also will be creating the root and creating the binary search tree. Okay, so this is the end of for loop and also end of your case 1. Okay, still we have to write the function definition for this particular function call. So it is very simple. Case 1 is done. So what is case 2? According to case 2, we have considered search operation. Okay. So in order to search an element, I should know what is my key element. Okay. Without knowing the key element, you cannot do the searching operation. Hence, first step in the case 2 is to read the key element. How do I read the key element? So using your printf statement, I can indicate that as enter the element to search. Okay, you are searching for the key element. So user should give the input for key. I'll give scanner percentage D ampersand data. Okay, I can consider the same variable because it is another case. So now after this, you have read the key element to be searched. Now you should have a separate function for doing the search operation. Okay. For doing that, I just call search function. What should be the input parameter for search function? Because your search will start from the root node. Okay, you start comparing from the root node. You have to pass the address of the root node and also you have to specify the key element to be searched. Okay, there should be two input parameters. First is the address of the root node. Second is the key element to be searched. Okay, finally, if it is returned, it will have the address of that particular node. Okay, so then you come out of the particular program or particular case. That is case 2. Then we'll go with case 3. Okay, so case 3 we have mentioned it as traversal. Okay, while doing the traversal, what should be passed as an argument? I have to pass the address of root node because you will start comparing from the root node. Okay, and there is no need of return value here because in the function itself you will be printing the values of in order, pre-order and post-order sequence. Okay, so this is the function call now. And in search also, this is a function call. Okay, so that is the end of case 3. What is fourth case? Fourth is exit case. Okay, so you can have exit 0 or return, anything is okay. If you want, you can add a default case. Okay, what can be the default case?
Invalid choice.
So it is for the wrong option or invalid choice. You can have any value. Okay. So then come out of the default case as well. So this is your main function. Okay, switch end the switch case, end your while one, and also end the main program. Okay, so main function is completed. So it is considered when you look at this function, it will be considered as very easy. Okay, so case one you should remember you have to give input for n and also fetch the data for each node, and you have to create the binary search tree. After it is created, next step is to go with the second case is to search the element. While searching the element, you have to specify what is the key element to be searched. Then you call the function search function. So for all this, you have to write the function definition. Okay, so let us start writing the function definition for each of the function call we have made. Okay, so we will consider from the first case itself, that is creation. I'll just write it before main so that it avoids function declaration. Okay, so what is the first case? First case is creation of a tree. Okay, I have to create the tree. So for creating the tree, I'll write the function definition, create tree. Can anybody guess what should be the return type of this? What will be returned after a tree is created?
Structure type.
So it is a structure type, okay, because you are going to return the address of a node, okay. I can directly consider that as node star, correct? What is node? Node is already defined. Node is a structure variable, and I can consider that as a node star. That will be considered as a function pointer. And input parameter. What are the input parameters for create function is, you can look at create function call. You are passing the address of the root node, and also you are passing your data, means the data in your node. Okay, those two things to be included. Okay, so what is your root node? It is also a variable of your structure type. Okay, hence what I'll be doing, I'll consider that to be a structure type and specify that as a pointer. Okay, because it should have the address of that particular node structure with data part, left child, and also the right child. Okay, this is for your root node. Okay, if it is confusing, instead of node, you can also specify that as temp. Okay, the next is int of data. Okay, so this is the input specified root node and the data. Okay, so using this, now I have to create the node. How do you create a node and allocate the memory for it? Normally, we have already done in singly linked list, doubly linked list, and polynomial. How to
Creating
create the node and allocate? So
creating malloc.
using malloc function. Okay, you have to use the malloc function. So for doing that, I need a temporary variable. Okay, so I need a temporary variable. So how do I assign? I can consider a temporary pointer. So using temporary pointer, allocate the memory. Afterwards, you assign the data part at the left child and right child. Okay. Before that, consider while creating the search tree, remember the concept that the root node should have the value, which is the tree should be constructed such that the value at the left part should have lesser values, and the value at the right subtree should have the greater values. Okay, so here in the input you are passing the address of the root node. Okay, when you are passing the address of root node, suppose if the value of this root node is equal to null, what is the meaning?
No elements are present.
So consider here you are passing the address of root node. Initially, what is the value of root? Is it equal to null?
Ma'am.
Okay. So when it is equal to null, now you are passing the data. Okay, now we are creating a temporary node. Whether this temporary node itself will be the starting node,
Yes, ma'am.
because since you are not having any node, suppose it is the first time you are creating the tree. When you are creating the tree for the first time, initially root node will be empty. Okay, in that case, what happens? The node which you are creating now, that itself becomes your root node. Okay, as for our example, since root node is not created, it is equal to null. So whatever the node I am trying to create now, that itself will become the root node. Okay, so how do I add the condition? Suppose if the node, okay, if the node is equal to null, if it is equal to null, then directly how do I start it? I can go with creation of a temporary node. Suppose if it is not equal to null, what happens? I have a condition that it should be checked for less than or greater than condition, because it is a binary search tree. Okay, let us understand that later. So we have some three conditions. Suppose if it is equal to null, the new node created itself becomes root node. Suppose if it is not equal to null, already tree null 2 or 3 nodes ಇದೆ ಅಂದ್ರೆ what happens? I have to identify whether it is less than that value or whether it is greater than that value. Okay, for doing that we are adding a condition now. So here, suppose, what is the condition? If tree is empty, okay, this condition will work. If tree is empty, means the root node is having the value equal to null. In that case, create a temporary variable and allocate the memory for it. How do I allocate the memory for temp? It is same as your previous examples. Okay, node star malloc specify size of node. Okay, so why do I indicate that with capital and small letter here is capital and small letter, it is different. Okay, this small letter will hold the address of the root node, whereas this node is just a structure variable. To differentiate that, I have made it like that. If there is some confusion, you can change this variable name. Okay, variable name can be changed. So then memory is allocated. So if the memory is allocated, now I have to assign the data part and link part for this temporary node created. How do you assign the value for data part? How can I access the data part for temporary variable?
Temp paramark data.
Temp arrow mark data. Okay, so temp is the node created. It has the address after successful allocation of memory. I have to use this operator, arrow operator, for accessing the data member. Okay, so it is equal to what you are assigning now.
Data.
Data.
So you are assigning data. Okay, so this is done with assigning the value for the data part. After data part is completed, next is I have to assign the left part and also I have to assign the right part. What is the initial value for left and right for the temporary node?
Null.
Null.
So initially I can consider that to be equal to null. Okay. Suppose if tree is empty, the temporary node itself will become the first node or itself will become the root node. Then what I can do? I can directly return that term. Okay. So this is the first if condition. Still there are few more if conditions to be checked. Okay. So if my tree is empty, the temporary node whichever you are creating, that itself will be the root node. Okay, this return value, it is going to return the address of the new node created to your root variable. Okay, in this root variable it will be holding the address. Again there is a repetition here, for loop based on the value of n, so it will be repeated. Okay, again you apply the scanf and call the create function. Okay, still some conditions to be identified here. Suppose if the tree is having some nodes, consider you have some nodes in the tree. In that case, I have to identify the conditions. What are the conditions? I have to check whether my data is less than that node or greater than that node. We have already done this in example. Okay, 1 second. example. Okay, let us have this condition itself. Consider you have created a node, 6 is created. After 6 is created, what is my next node? Next is, it should be 5. Okay, so how do you write the binary search tree and how do you compare it? It should be compared with the root node. Okay, so I should have a condition. What is the condition? I have to compare 5 with 6. Okay, 5 should be compared with 6 and you have to check whether it is greater than or less than 6. You have to check whether it is greater than 6 or less than 6. So if it is greater than 6, you append to the right part. If it is less than 6, you append to the left part. Okay, that is the condition. So in if condition, you have two variations here. What are the variations? I have to check 5 with 6, check whether it is greater than 6 or whether it is less than 6. Okay, according to our example, since 5 is less than 6, I will be appending that to the left part of the root node. Okay, because it is having the lesser value. Okay. Now you have to add this condition. In the first condition, initially we had root is equal to null. Okay, so when you have root is equal to null, the new node will become equal to your root node. What is the new node now we have created? Consider 6 was my new node. Using temp I have created 6. Okay, so for these two conditions, greater than and less than condition, I have to add a C implementation. Okay, can anybody think of that situation? How would you add that? What should be my if condition? I am comparing the data. Data is the new node which you are trying to insert. What happens if the data is less than, what is your root? What is the variable used here for root?
Node.
Node. Okay. How do I fetch the data part of a node?
Arrow.
Arrow mark of data. Correct? If the data is less than the root node. Okay. Here you are comparing if data is less than root node data. Okay. Now what happens? Where do you add this?
Left
Node of
Left is equal to
Correct. So it should be added to the node of left because it is having the lesser value. Data is having the lesser value. Okay. So now what happens? Can anybody tell me this condition? In ಮಾಡ್ತೀರಾ ಇವಾಗ? I am trying to add a node to be added. That node to be added to the left part of the root node. Okay, left is already indicated. Now I have to create the node again. How do you create the node?
using malloc.
Is it required to call the malloc function again? Can I recursively call the same create function?
Yes, ma'am.
Okay, so this is an example of recursion where I'll be calling the create tree. Okay, create tree is again called. Now tell me what happens to the root node now. What happens to the root node?
It is null, ma'am.
Huh? No, which one should I pass here for creation of the tree?
Left node.
data.
Data should be passed along with, you should pass the address of the node where it should be appended, right?
Yes, ma'am.
So which one will you pass?
Ma'am, left node.
Data of left.
So I have to pass the address of that left node because I have to create a node and it should be assigned to the left part. Okay. And what is the another variable? That is the new data. Okay. So this is the condition where the data is less than the root node data. Okay. Suppose you have another condition. What is the another condition? I can have, sorry, 1 second. Okay, I can have else if condition. Else if, what is the another condition? Suppose if data is greater than the root node data, okay, node of data, then what should be done?
Node of
Node
right
of right is equal to
to the
create tree.
tree.
Node of right is equal to, again I have to create, correct? So what will you pass now?
Node
Node
of
of right.
right data.
Node of write and data. Okay, so this is the end of this particular case. Okay, finally, after creating all the things, then you can return the address of that particular node, which will hold the address of the root node. Do you have any other condition required here? Is it creation done?
Ma'am, if it equals to that data, what we can do, ma'am?
Which one?
ಮ್ಯಾಮ್ ಅವೆರಡು ಈಕ್ವಲ್ ಆಗಿದ್ರೆ ಏನ್ ಮಾಡೋದು?
One more thing, while considering the binary search tree, okay, so whenever you consider the binary search tree, you should take care of specifying the duplicate conditions, okay, so you should not have duplicate values given for the binary search tree. Okay, suppose duplicate values bandre, what happens here? Can you people think of what happens if duplicate case enters to this situation? What will be returned?
ನೋಡ್
Node will be returned.
Node itself will be returned. So what node will be having? Will you be having that root node address?
ಎಸ್ ಮ್ಯಾಮ್.
Yes, ma'am.
Okay, so it will be having the address. Root node will be the root node of that particular subtree in that iteration. Okay, so it will not consider the duplicate values. If you have a duplicate value, you will not be executing any of these conditions. Okay, if particular conditions execute agala, you will skip that particular part and you are going to return only that particular address of the node. ಆ subtree ನಲ್ಲಿ root node value address ಏನಿರುತ್ತೋ ಅದನ್ನ ಮಾತ್ರ ಪಾಸ್ ಮಾಡ್ತೀರಾ, so that it will not be added to any of the left part or it will not be added to any of the right part. Okay, you will just whatever the node existing already one the duplicate value ide andre, you will just pass the address of that. Okay, that is how you have to handle the duplicate cases here. According to binary search trees, you cannot have the duplicate values, but by mistake, if you enter the duplicate values, so any of these cases will not be considered. Only thing is you are going to return the address of already existing node, so that it will skip creating another node. Got it?
ಎಸ್ ಮ್ಯಾಮ್.
Okay, so this is how you have to take care of creating the binary search tree. One is if the node is empty, the new node itself will become the root node, or you have to check for the condition if data is less than the root node. So in that case, it will be added to the left part. When you are adding to the left part, for that part also I have to create the temporary node, or I have to create the memory allocation for that. So pass the value of that left address and also the data. And next condition is you have to check, okay, what is the condition here? If the data is greater than the root node data. In that case, so you have to append that new node to the right part of that particular node. For doing that, call the create function again. It is a recursive function call where you will be passing the address of the root node and also the data part. Okay. Finally, if any of these conditions is not true, what you do, you directly execute the return node function. Okay. It will take care of the duplicate values. Any doubts? Is it easy?
ಎಸ್ ಮ್ಯಾಮ್.
Any doubts understood?
Ma'am.
Okay, so this is how you have to remember the logic. While remembering the program, you have to check if my root node is null, create it and return that. If it is not null, then append to the left if data is lesser and append to right if data is greater. Then in any other case, you return the node and also you return the node after doing all this operation, which will hold the address of the root node. Okay, so this node will be returned to your case 1, okay, where you will be calling the root node. Root is equal to create tree. That is the case 1 function call, that is creation of the binary search tree. Then we will move on to searching case. Okay, that is the second operation, searching the key element. We will write the function for that. So even after searching, if you want to return an item, that is the data to be retrieved, in that case, you can specify here as int search can also be specified, or you can also specify it as node search. If you are trying to return the complete node, you can have it as node star search. What are the input parameters for that search? That is the address of the root node and also the key element to be searched. It is same as the previous creation option. Okay, I'll indicate it as node star node int data. Okay, so according to our rule, how do you search? If tree is empty, can you search?
No, ma'am.
So how can I add the condition for that?
Node equal to null.
So if node is equal to null, I can say that tree is empty, correct?
Yes, ma'am.
Yes, ma'am.
Okay. Tree empty antanadru haki or tree empty or element not found. Both are okay. Okay. If it is equal to null, suppose the root node is equal to null, I cannot do the operation. Okay. Else if now your searching should start. Okay. So when you start searching, definitely you will be starting with the root node. Okay. Your data should be compared with the root node. So what are the conditions you will get for searching?
Less than root node, greater than root node.
So it is same
Equal
as
to.
the previous. Okay, equal to and also less than and greater than condition, correct? So you have to add the condition for all the cases. Suppose if my data is less than my root node data, what happens now? Where it should be moved?
Left part.
So it should be moved to the left part. Okay. In the left part, what you have to assign here? Any guesses? Can I directly add it to the left part?
No, ma'am. Again we want to compare.
Again, in that left part also you will be having a subtree, correct? In
Yes,
that subtree also you have to search and check whether it can be added to the left part or the right part. Okay. For doing that, I can again call your search function recursively and specify the value of the address of its left node and the data. Is it correct? What happens if I call this search function again? Will it check that left part again?
yes, ma'am.
Okay, so I'm calling the search function again here so that its left part address will be passed to the root node. Okay, again it will check whether it is equal to null. So if it is equal to null, rather than specifying it as tree empty, I cannot directly say that as tree empty because it is a recursive function call. I can say that element is not found if it is equal to null. Okay, then you check for the other case. If it is less than the particular data part, again you have to check for the left part. Okay, it is a recursive function call where you have to search for the complete subtree in the left part. Okay, whether it is equal to your data or is it less than the data. Then next you should have another condition. Else if. Now you can easily tell me the next case. What is the next case?
Data greater than node of data.
If data is greater than node of data, what should be done?
Node of right is equal to.
So I should move to the right part. Okay, node of right is equal to call the function again recursively and pass the value of right, correct?
Yes, ma'am.
Okay, so this is for the right part. What is the remaining case?
Equal.
How can I write it? Else, can I directly print it? If it is equal, I can say the element is found, right?
Yes, ma'am.
Yes, ma'am.
Okay, if it is equal, I can all other cases we have checked with if else if cases. So last case, else case, it is a found case, element found. Okay, if it is equal, the element is found. So no need to specify that data is equal to node of data. It is not required because that is the last case. I can indicate that element is found. The element found is, suppose if you want to print that element also, you can print that, okay, by giving the space here. Then
Ma'am,
specify. How do you
ma'am,
print the data?
ma'am,
What should be specified?
ಮ್ಯಾಮ್ ಏನಾರು ನಾವು ಎಲಿಮೆಂಟ್ ಟ್ರೀಲಿ ಇಲ್ದಲೇ ಇರೋದ್ ಕೊಟ್ರೆ ಆದ್ರೂ ಅವಾಗ ಫೌಂಡ್ ಅಂತ ಕೊಡುತ್ತಲ್ಲ ಮ್ಯಾಮ್.
ಹೆಂಗ್ ಕೊಡುತ್ತೆ?
ಮ್ಯಾಮ್ ಅದೇ ಆ ಟ್ರೀಲಿ ಯಾವ್ದಾರು ಎಲಿಮೆಂಟ್ ಇರ್ಲಿಲ್ಲ ಅಂದ್ರೆ ಆ ಎಲಿಮೆಂಟ್ ನ ಫೌಂಡ್ ಅಂತ ಕೊಡುತ್ತೆ ಮ್ಯಾಮ್.
How? It will not come to else case, right?
ಮ್ಯಾಮ್ ಕೊನೆ ಕೇಸಿಗೆ ಬರುತ್ತಲ್ಲ ಮ್ಯಾಮ್.
No, if see, consider if node is equal to null at takshana, it will print that it is element is not found, right?
ಎಸ್ ಮ್ಯಾಮ್.
Then how will you go to else case? It will not go to else case. Whenever it becomes equal to that particular node, directly you are printing that the node is, the data is found. If it is not found, you print that it is not found, correct?
ಎಸ್ ಮ್ಯಾಮ್.
See, in these two cases, left, you will search for the left part. If it is found, you print that it is found. And you check for the right part. If it is found, you print that as found. Suppose in both the cases, if you are unable to found, in the last case, the node will be equal to null, correct?
ಎಸ್ ಮ್ಯಾಮ್.
Okay, in that case, what happens? It is directly going to print that element is not found. Got it?
ಎಸ್ ಮ್ಯಾಮ್.
Okay, so now how do you print the data part of that node?
ನೋಡ್ arrow mark data.
Node arrow mark data. Okay, so then finally you return the, what do you return? What can be returned?
Node.
I have to return the node, okay, because node is my, I have considered node as the particular return. Actually that is not required. You can also specify that as void, because to pass the address of the particular node, because in case 2 we have considered that as root is equal to search, hence you are passing the address. Suppose if you directly call it as search, no need of returning anything. You can consider void also. But better to have the starting address of the root node. Okay, so this is the search function, which is very simple if you remember the concept. Okay, if it is null, we say that element is not found. Then check for the lesser condition, check for the greater condition. If in any of this else if condition, if the data is found, you print that data is found and print what is the data you have found. Okay, so this data is passed from the main function. Okay, finally you return the particular node. Okay, any doubt in the search function? Everybody understood?
Yes, ma'am.
Yes, ma'am.
Okay, so case 1, case 2 is done. Now we'll go with the case 3, that is traversal. Okay, as I said, traversal you can divide it into different cases. So better to have the single case, no need of giving the choice every time. So here you are not returning anything directly. I can call it as a traverse. And what is the input for this? Input is the address of the root node. Okay, when you have the address of root node, I can define that as a variable of the structure type. Okay, so in this traverse function, it is just the display purpose I am using here. Okay, in order traversal, in order traversal, just for printing. Okay, now you have to call the in order function by specifying the address of the root node. Where do I get the address of the root node? By variable called node. Okay. Similarly, you go with why we are using this function. Actually, this function is not required, just for reducing the choices. Okay, user should give choice for each of the cases, like in order, pre-order and post order. To reduce that, we are using this function. That's all. Okay, so then passing the address. So all these are function calls. This is a function call. Similarly, we have to write the function definition. Okay, still we have to write the function definition. Then finally it is post order traversal. Okay, so post order of node. Post order. Okay. Okay, so if you want some space, you can just give /n. Okay, so we have three function calls. Then we have to write the function definition for each of the cases. Okay, so this is a traversal function. So if you just call this function, it will display all the three methods, like in order, pre-order and post order, rather than having it in the different switch cases. Okay, now let us write the function definition for each of the cases. All these three already we have studied in theory class. Can you people able to recall this? Okay, I am just giving you the input. Tell me what should be your in order function. If tree is empty, can I continue?
No, ma'am.
No, ma'am.
So what should be the condition?
If of node.
If of
Node
Node.
equal to null.
If of node.
If of
node
node.
equal to null, Nidra, can you continue?
No,
No.
no, ma'am.
Node should be not equal to null, correct?
Yes, ma'am.
How can I alternatively write this?
If of node.
Node.
If of node, I think in theory, while explaining, I have explained like this: if of node, if of PTR, correct?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, you can use any one of these. It is not mandatory that you have to follow that if of node only. If that is confusing, you can just go with if node is not equal to null. So if it is not equal to null, what I have to do? What is the procedure followed for in order traversal?
Left child.
So in order, it is a recursive function call. Okay, how do I write it?
In order.
In order.
In order,
Node arrow mark left.
Node left.
node of left. Okay, then
Printf.
here you should have the printf statement for printing.
Node of data.
Correct, node of data. Then
In order.
In order. Node of
Node of right.
in order, node of right. Okay, is it done?
Yes, ma'am.
So this is the same function we already discussed in the theory class as well. Okay. Similarly, now we have to write it for pre-order on post order also. Okay. I'll just go through with this because it is already discussed in class also. Okay. If node is not equal to null, I can continue. Okay. There is no return type, hence we have considered it as void. Tell me now.
Printf.
Pre-order.
printf.
So in pre-order, you should have the printf statement. Okay, %d. We are going to print the node of data. Okay. Afterwards,
Pre-order.
Pre-order.
Node of left.
node of left. Okay. Then pre-order,
Node of right.
node of right. Okay. So this is about pre-order, then specify post-order. Okay, post-order of node. So I can continue only when tree is not empty. If it is not equal to null, then specify printf. Sorry, not printf. Which one is in post-order?
Node of left.
Node of left.
Post-order, you will be considering node of left, then
Node of
Node of
right.
right.
post-order, node of right, okay,
Printf. Node
and
of
we
left.
will have a printf statement, okay. Node of data. Close the if condition and also finally the brackets. Okay, so is it all the cases done?
Yes, ma'am.
Okay, so case 3 it is completed, case 4 is exit and default case. Okay, this is how you have to remember the logic. Okay, actually deletion is not given in the question. We will study how do we delete and implement it in C in the theory class. Okay, I just execute this program. vsearch.c. Okay. There are 4 errors. Type mismatch in redeclaration of in order. Okay, where is the type mismatch? We missed anything? Declaration terminated incorrectly. Sorry, for main we have added semicolon. Okay. And type mismatch in redeclaration of in order, pre-order and post-order. See what we are doing, we are writing traversal function first, right? One second. See, what was the mistake earlier is, see, in traversal we are calling the function, but it is not defined earlier, correct? The mistake was before writing this particular function definition, what I have done, I have written this void traverse function. But in void traverse, what happens? You are calling the function called in order, pre-order and post-order, and there is no function declaration and also definition before this particular program. Okay, make sure that you are going to write the function definitions of in order, pre-order and post-order before your traverse function, or you have to specify the function declaration. Got it? Understood the mistake?
Yes, ma'am.
Okay, so now we have to enter the choice. I'll give choice 1, give the value of 5. Okay, so make sure that you note down the values of n. Okay, whatever I am typing, just note down the values 5, 12, 6, 4, and 2. Okay, so this is the value given 5. Second option, that is for searching. Okay, I'll give choice to specify the element to be searched. I'll give 12. Okay, so the element found is 12 because we are also printing the data. It is specifying that element is equal to 12, and I'll also give some other value for searching, choice 2. Then specifying 9, 9 is not there. It is printing the element not found because 9 is not there. Okay, so now I'll give choice 3. Okay, when I give choice 3, it should display all the traversal methods like in order, pre-order, and post-order. So can you people verify that is it true for 5, 12, 6, 4, and 2? Construct the tree first. What is the value given? Input is 5, 12, 6, 4, and 2. Okay, what is my root node? Root node is equal to 5. Okay, 12, where do you place 12?
Right child of 5.
Right of 5.
So, ray 12 to be placed to the right of 5. What about 6?
Left of 12.
Left of 12.
6 to be placed to the left of 12. Okay, then 4,
Left of 4. 5.
left of 5, 2.
Left of 4.
Okay, so this is the tree constructed. According to our program, it will construct this particular tree, okay, based on the input given. Now, you have to check with the in order, pre-order, and post-order whether we have got the correct answer or not. Okay, so tell me the in order for this.
2,
2,
4,
4,
5,
5,
5,
6,
12.
6,
12.
12. Okay, pre-order,
5,
5.
2,
After 5,
4.
4,
4,
2,
2,
12,
12.
12, 6. Okay. Post order.
2. 2. 4.
4,
6.
6,
12.
12,
5.
5. Okay. So let us see whether we have got the same result or not. Check with our result. Is it visible if I just reduce the screen size?
Yes, ma'am.
Compare these two. Is it correct?
Yes, ma'am.
Yes, ma'am.
Okay, so we have got the same result. How do you check whether the tree is constructed properly or not? I cannot check it because I cannot display the tree structure. So what you can do is you write the tree on your own. Then after writing, you write down in order, pre-order, and post-order. If your result and the result which you got after executing this program, if both are same, then you can say that your tree is constructed properly. Got it?
Yes, ma'am.
Any doubts? Then 4 is finally the exit case.